Good morning. Today we are going to see the one more experiment in this physics 2 course, which is experiment the temperature dependence of resistance. And the objective of this experiment is to demonstrate the resistance of a light bulb filament is non-linear and to determine its operating temperature. So these are the devices that we are using to complete this experiment: a power supply and a DVM, digital voltmeter, and another digital voltmeter. One is to use to measure the voltage, the other one is used to measure the current, and also a bulb which have a tungsten filament. So the basic idea behind this experiment is the Ohm's law. V is equal to IR. Everybody knows it. It's very easy to understand the Ohm's law. The voltage is equal to current multiplied by the resistance. There are two parts in this experiment. One is the ohmic range, the low voltage part, and also the high voltage part. It's quite easy. Just keep the voltage in the power supply, DC power supply, and measure the current and calculate the resistance. So to keep the voltage, this is our power supply. We have two dials. One is for the current and the another one is to fix the voltage. This is to fix the voltage. This one, no need to do any adjustment. So the voltage dial, we just rotate it and keep it at 0.1 as an input volt. When we give 0.1 input voltage, and we will get the corresponding current in the digital voltmeter. This is our current for 0. It's not 0 exactly 0. Yes, this is 0.1. So you take down the value and write it here, and then the second one, change the input voltage to 0.2 by rotating this dial and measure the current. Keep on increasing the input voltage and measure the current from the digital voltmeter. After that, use your calculator, find the value of R, which is the resistance. R is equal to V divided by I. That's the first part of the experiment. And the second part, just a continuation of the same for the high voltage range, which is for 1 to 12. You can easily see that we're starting from 1, it will finish at 12. For each input voltage, measure the current in the digital voltmeter. So again, we have to adjust this one and keep it as 1 as a input voltage. This is input voltage is 1, and this is our output current. When we keep on increasing the input voltage, and at one particular time you can see the bulb filament starts to glow. That's the operating temperature. That's what we are going to find in this experiment. Each time give the input voltage and measure the current and record the values over here. Finally, use the calculator, calculate the value of R. After that, we know that we have to draw a graph for these two data. One is for the ohmic range, the other one is for the non-ohmic range. For the ohmic range means for the lower voltage value, for a non-ohmic range is for the higher voltage value. From the first graph, we can easily find the value of R0, and from the second graph we can find the value of R. Using these two values and also our basic formula, R is equal to R0 into 1 plus alpha into T minus T0, find the value of T, which is the operating temperature. Alpha is the temperature coefficient, T0 is the room temperature. All are known values which will be given, and these R and R0 are from the first two graph. From the graph 1 we will get the value of R0, from the graph 2 we will get the value of R. Substitute all the values, find the value of the temperature. T0 is the conductor at the room temperature, and temperature coefficient of resistance is alpha. All the values are given. Alpha will be given and also T0 will be given. You can see here alpha for tungsten is 4.5 into 10 power minus 3 per Kelvin kilo power minus 1, and the room temperature we can take whatever we want, the 25 degrees Celsius or maybe 26 or 24. Use all these values, find the value of the operating temperature of the given tungsten filament or the given bulb, and write any two source of error and also the conclusion. Conclusion is based on the objective of this experiment. That's the end of this experiment. Thank you.